Hello, everybody. So we just got done talking about whether predation affects the prey numbers, but now I want to talk about, does predation actually affect the diversity of a community? Now, a lot of this work was done by Robert Payne. He was a guy who did a really famous ecologist that did a lot of work on rocky intertidal zones and a lot of what we'll see. We'll be talking about keystone species here a lot. That idea kind of came out of this work. Now, where he started was he spent a lot of time in these intertidal zones and was really struck by the diversity of this rocky intertidal community. Now, this was mostly looking at sessile invertebrates. The marine invertebrate or the animal invertebrate, that's kind of redundant. But what I'm saying is the animals that are living in these intertidal zones between, low tide way down here and high tide when the water is covering over these rocks. Now, it seems that there's really only one really important, highly sought after resource, that resource being space. We don't think of space necessarily as a resource, but in this case, you can see that these barnacles and these mussels are really tightly packed in here and really fighting over who gets what space. So it's really surprising that when we have this one really sought after resource, that we get so many different species. And so they kind of thought that this went against that competitive exclusion principle. So what they did was they noticed that there was these starfish, sea stars, specifically the genus Pisaster. But really, this is a whole story of how the Pisaster, the big predator, the main predator in this system, is going after and maintaining this community of chitons, limpets, bivalves being the mussels, acorn barnacles, and these gooseneck barnacles. Now, it's maybe important to remember that chitons are scrapers. They're going to be scraping off the rocks, getting the algae that's growing off in here. Limpets are doing the same. Bivalves are filter feeders. They're going to be filtering the water. And both the barnacles are actually filter feeders also. They do it a little differently. These are arthropods and these are mussels. But they're pretty much eating the same food source here. But they're all using space, right? So what we see is, the chitons are moving in between here. They're really stuck hard. They're kind of like a snail with a hard shell over the top. Limpets are like, imagine like an ice cream cone, a waffle cone that's like more, not so long of a waffle cone, but it's just kind of like a cone with a snail under as the ice cream stuck onto a rock. That's what those things are. So we've got all these 5 prey species essentially, and the starfish can eat pretty much any one of these. But what we see it does is it feeds preferentially on the mussels, the bivalves. So what Robert Payne did was he spent a bunch of time trying to take starfish and keep them out of certain areas. Now, starfish are moving extremely slow, but those things stuck to the rock are moving even slower, right? The mussels that are completely unmoving, they can't really escape from that super slow moving starfish. But so it's relatively easy to keep out these starfish. But what happened was they had the control with the Pisasters, or the normal community of what the starfish being there, and then a exclusion community, a bunch of them, where they tried to keep the starfish out of there as best as possible. And what happened is what they saw was the bivalves, the mussels, really increased in number. And pretty much the chitons went away, the gooseneck barnacles went away. There were some limpets and some acorn barnacles, but realistically, it was completely covered over these intertidal habitats with these mussels. So Robert Payne came up with this idea of a keystone species, where a keystone species is a species that disproportionately affects its environment relative to its abundance. So this is what, the real data, where they had a whole bunch of species present on these rocks with the predator, with the starfish, but without the possessor, without the starfish, that diversity really declined and stayed really low at just 2 or 3. I think this is 1, this is 2, right? So you basically just got a whole patch full of mussels, those bivalves. Now, there's some caveats here. It's not like all predators do this. It's only keystone species they're oftentimes predators, but they're only going to be keystone species when they prefer a competitively superior prey. Okay, so let's go back here to think about a different scenario where we've got, let's say these starfish are eating up the chitons and the barnacles first, right? Like that's what they prefer to eat. They would basically clean off the rock of those chitons, those barnacles, and then you'd be left with, this situation being the what happens when you allow the starfish to be there. But that's not the case, right? These starfish are eating the bivalves, which also happen to be the competitively superior prey. So when you get rid of the predator, those superior competitors crowd out everybody else and become numerically dominant, like completely covering the whole system. So keystone species are these like really important species that can not be all that common, but their effects will filter down into the entire community, maintaining it at high diversity. Now what we see though is this keystone effect really is dependent on prey density. Okay, so if there are not a lot of prey, so let's think about way down here on that logistic growth curve, there's essentially no competition for space, right? Because there's a lot of resources available. So the predator really doesn't increase the diversity in this case. It wouldn't do it. Another example of the really common keystone species example is the Yellowstone and the wolves. Okay, so pre-wolf, in the 1980s, 1990s, there were no wolves in Yellowstone, and the elk numbers got to be super huge, right? And we have all these elk literally all over Yellowstone. Eating up all of the vegetation, so I've put the land here as like a gray or a beige color, right? They start to increase. They put in wolves and really decreases the number of elk in the park. And what we see is there's this like spring of diversity because they've changing the behavior of the elk and reducing the elk numbers a little bit. And really change the community. The thing is, though, if the elk were, had started out in this number, if the 80s and the 90s there weren't that many elk, we wouldn't have seen this big impact of wolves. If wolves were to come into this, low prey density, they wouldn't change anything about the community. It has to be in situations where there's a ton of prey, when those predators come in, will have a big impact. And we see this pattern repeated out, pretty much wherever we look for it. Without high prey numbers, predation just really doesn't matter. So when we look at is predation important from that individual, the evolutionary level, the ecological level, there's all three guesses. Now, this isn't really meant to be that it's less important for individuals, but yes, predation is important at all three different levels. The thing is, the strength of that effect is really variable across what type of organisms we're talking about and their individual adaptations, what type of ecosystem we're talking about, how many trophic levels are in the ecosystem, how many, and then the community structure. So how many, what is the current abundance of the prey items in that community? And we can see that predation levels will be high, or the effect of predation will be highly variable.